Alright, in this video we'll continue with the properties of a function in section 2.3. Now this is one of the handouts that are found in your documents for week 3, so if you want to figure it out first and then come back to this video and check your work, that would be, you might want to pause this and then do that and come back. So we're moving on to this worksheet found in your documents folder. So we're just going to run through this. This function looks like it's this graph is a function. It passes the vertical line test. There's only one value of output for every input. So if I input 3, my output is 50. If I input 0, my output is 0. If I input 1, my output is 15. And then so forth. There's only one value for every input number. We're only going to get one value out. So that's what we're asking for in the first one, is what is our output when our input is -3. So we're going to, and this is an approximation, so we're going to read the graph. From the graph we're going to read up from -3 and then across approximately to where it is. So we're looking at a little more than 30, I would say maybe 31 there for our answer. Approximately 31. We could approximate at about 30 as well. Looks a little bit bigger than 30. So f of negative, or that's f of -3. F of +3 is also an approximation. If we go up to it as well, we're running up to +3. We go across. So we're going to get close to 50 there. So I'm going to put approximately 50 on that one. So those are my values approximately. Okay, then it says estimate the values of x where the answer, the output is 20. So what we would do there is we would look at our output at being 20. This is our output of being 20 right here. We would want to find out when that occurs. So it's going to occur to the right of 20, and it's also going to occur to the left here. So we're going to have two values where that occurs. So we're saying if we say to the right it's 20, approximately just a little past 1. It's not 1.5. Here's 1.5. So maybe 1.25. So I'm going to say 1.25 or 1.25. And I'm also going to say it's going to be back here at -2. I'm going to say -2.75. And these are approximations, so we're somewhere in that area is going to be our solution. Now it's increasing, so we want to look at where it's going up. And it is going up from this point right here. It's going up as we until we get to this point. So our interval is going to be from here, which is 4, and from here, which is -1. So our interval for increasing would be -1 to 4. We don't look at the y values. That's just where our maximum minimum is going to be. So in the next question, they're going to ask us for that. So our local maximum occurs right here. So our local maximum is going to be 56, maximum value of 56. That's how high it is right there. That's the maximum it is locally. When x is going to be 4, that's when that occurs. So you want to know when it occurs. It happens at 4. The minimum value, similarly, the minimum value is down here. This is our minimum value. So that's going to be a minimum value of -6.5. And that occurs when x is -1. Okay, and then we have some true-false ones here. This is saying f of 2, so the value of the function is going to be greater than 0. What it's asking there is the y value at 2, is it higher than 0? So if we travel up to 2, and we travel up, so f of 2 is going to be right around 35. So this is true, it's greater than 0. True. Is f of -2 greater than 0? So f of -2 is right here. It is also above the y-axis, so we're going to say true for that as well. it is a positive value. And then it's going to ask you if f of negative 1/2 is a negative value. So here's negative 1/2 right here. When we look at this value, we'd say that is also true. It is a negative value. It's less than 0. So all your answers there are true. If you have any questions, you can send me an email.